Hello, hello, hello. Can you hear me? Yeah. Okay. Saudi Cap, everyone. I'm Jonatas. I'm really happy to make this presentation to you and share a bit about my process, how to leverage your knowledge and how to transition between blockchain stacks. I'm starting talking about me. So I've graduated in computer science. I've worked 5 years as web and mobile developer. During these years, I worked with PHP, React, React Native, and a lot of stuff. Right now, I'm 2 years working at Spearbit as associate security researcher. And one important migration between my career was I was working as React Native developer, and then appeared opportunity to start working as Flutter developer, and then I have only 1 month to change between stacks, and this, like, all of this experience brings me here to show you more about how can I use this process to learn new languages. So my proposal here is to get you a starting point to migrate your knowledge in Solidity and start learning Rust, and also do it fast, like not watching tons of videos and lost too much time to make these kind of migrations. The agenda today I separated in 2 main steps. So the first one is the developer mindset. So we are going to check the difference between the blockchain stacks and understanding the code, then researching the framework, and then I will bring you a code here that we can read and understand the most of logic of it. And the next step will be the hacking mindset, so that you can use what you already learned in Solidity and bring it to the Solana blockchain. And the last one is the conclusion. So already starting the difference between everything that you can see here, I didn't get it at the first moment that I started learning Solana. So it will happen like in a cycle, so you can get the basic stuff, and while you get deeper in the code, you can learn more. But just to bring you some basic stuff, like in Ethereum, you have one ETH they have 18 decimals, and one way is the last amount. In Solana, we have the Sol, and they call it Lamports, and have only 9 decimals. In Ethereum, usually you have only in the single code everything together, like the logic key and the data, where you can store everything. In Solana, we have 2 different types. So you have a logic program and a data account. Then in transaction in Ethereum, you can only call a single function, like when you send a transaction. In Solana, you can call multiple functions in the same transaction, use different signers. So have multiple signers as well. And in Ethereum, we have the pre-compiled contracts. In Solana, we call it a Solana program library. And it have the main basic contracts that you can interact, like to create token, some kind of this stuff. And in Ethereum, you have the self-destruct. Right now, it changed a bit. But in Solana, you can also close and delete the account. So you have to close it properly and to not have any kind of issue. And another interesting stuff is that in Ethereum, you have the create2 that you can derive the account from it. You can predict the address of it. And in Solana, we have the PDA, which is the program, sorry, let me close this. Okay, so we have the program derived address, which is the PDA. So usually when you want to create some data account from a program, you use this kind of structure. So starting already with the coding language. So in this step, you don't want to have a deeper understanding of how the Rust program language works. You just want to have like an overview of it. So you don't need to understand everything that you pursue. You can understand step by step. And we are going to do it by having it in parallel of how Ethereum works. So in Ethereum, we have the primitive types, that is the uint, int, address, boolean, bytes, this stuff. Then we have how to declare this variable. So we use this primitive type and then the name of the variable. Then we have this array type, how you use it. Probably you all know this, but it's how can you do it, compare everything. Then we have the array. Then we have the mapping that you can map an address to an integer, like checking the balance. A user could have, so we have this declaration. Then we have the structure type, where you can have like a person, car, or anything, and you have like the name. In this example, we have the name and then the age. So a person, you can declare a person like this way. We put the person P, and then the name, the age, and if you want to change, you can directly change the name just adding this. We also have the enum, which is just to add like a type to something and bring it to Rust. We have similar things. So we are going to have the primitive types. So we have U represents the uint, and it goes to 8 to 128. Then we have the integer, the boolean, bytes. It's kind of similar. And how to declare a variable. So you use the keyword let, and then put the name. Then next is the type and the amount, and the value that you want. So if you want to declare an array, you need to use the let, and the mut keyword in this case is used to let the variable be changed. So in this case, if I want to add values to this byte variable, I will need to use the mut keyword. Then I can access any value and index in the array and can change it. Without this mut keyword, if you try to change the variable, you're going to get an error from it. We also have the structure types. So in this case, the user, you have like the Boolean active and the username. And this case is quite similar to Solidity, but the type is after when declared the variable name. Also, we can declare the user like this. You have the mut keyword again, and you set it. And if you want to change the username, we'll just add like this, a string from, and change it. We also have the enum. It's pretty similar too. And like you can add this deposit withdrawal types. So right now we just have like an overview of how Rust works, and you can already start read some code. But first, we need to learn how to declare and also use functions. So again, comparing the Ethereum and Solana, Solidity and Rust, we have like to declare a function, we have the keyword function, then the name of it. We declare the input type, so we have uint 256 A and B. Then we have the visibility of the function, and if you want to return anything, you add the keyword returns and the type of returns, the type of it. And to return, we also have the keyword return and return the values, right? So to use this function, we can declare these two variables, A and B, and to use it, you just call the function and pass the inputs. Now take a look in the Rusty. We also have the visibility first, so it's a public function. Then we have the keyword fn, which means function, the function in Solidity. Then we have the name of this function. We have also the input type, so A and B, but it's quite similar. We add the type before of the name of this function. And to use it, you declare these two functions and just use normally like Solidity. So there isn't too much difference to get the basic knowledge of Rust. From now on, you can already identify some parts of logic of the code. And then there are also some different syntax from Solidity. Here we have the for and while loops. So in Rust, we can declare the for using this syntax. So we put the for and then the name of this variable and the range of it. And then you loop through this code. And the while is also quite similar. So you can see that you can just read everything normal and pretty understand it, the code. Okay, and we have the also if-else statement and the match. So the if-else, we don't use the brackets. We use the if keyword and then the cooperation, the statement inside to check if it's equal to something, and then else if, else. It's pretty straightforward, everything here. Then we have the match. The match is similar to the switch case, where you can see in some cases, so to match the number, if it's equal to 1, you have this print. If it's equals to 2, you have the another one. And in case of default, we have the another print. This and this. And now, like we have an overview of the code. We can already start jumping to the framework. We don't need to spend too much time studying complex stuff and know how to work and spend really much time understanding the language, watching videos, and all of this stuff. And we can check how the architecture of a program works. So we have the Foundry. In Foundry, everything can be found in these three folders. So we have the script to run, the tests, and the source. In the source, we will have the main logic of the code, right? So you can check here that we can declare a contract counter, which is the most basic contract here. So we have the number, and then this number we can just increment it. And we can also set it or anything else you can do in this code. We will do inside this contract, the counter contract, right? And okay, and now we can check how the Anchor framework works. So there is like a lot of files here. It seems like a mess at the first look. And looks like pretty complex if you don't understand anything. But if you can check this folder here, we can see that our program is defined inside it. So similar to the counter, we will have a source folder. We have the program. Then we have the name of our program, which is counter. And inside it, we have the source folder. And inside the source folder, we have the lib file. So the entry point of it, it's the lib.rs file. Then we have a bunch of code here also. You don't need to worry that you don't understand everything, because at the first time, as I said, we don't need to understand it. We just need to understand the logic about it. But to get a better overview, this rectangle will have the declare ID. In Solana is a little different because we define the public address before we create the program. So we add this value here. Then we have the program macro. A macro in Rust is it's like a function that will run background and make something easy to you, so you don't declare everything from the beginning, right? So you have our program counter here. In Solana, we also, as I said, we have the program and the data account. So we have to initialize this data account before using it. So usually when you start looking at the code, you will see an initialize function. In this case, we have the initialize counter function. And we also have the increment function here. As you can see, the inputs here, that's a lot of weird stuff, but we are going to check in a while everything. And we also have the inputs declared here, which is like the initialize counter. They have like a payer and the counter. So we are starting a data account called counter. And to use it, you have the struct called increment above, right? So the idea until here is to understand where we can find the files in the framework, because usually when we open a project, that like in a language that we don't know, we don't have any idea where to start and begin reading the code and check the entry points, all this stuff, right? Let me. So we have an overview of the project architecture and how to read some small pieces of code independently. And right now, my idea here in my process, before I understand the code and the file architecture, is to already start reading a code, like get deep. Because when you read too much tutorials, you can spend too much time reading it, and when you go to a real case, the file architecture is completely different from what you see in these tutorials, right? So let me, where is my mouse? Okay. Right. So I got, I think you can see better now. So I got this code from a competition, a grass competition. They have 3 programs, but I think we can have time to understand probably 2 of it, or 1, I'm not sure. But we have the road staking and the token airdrop. So if you have an idea how a token airdrop works in Ethereum, usually you have a Merkle tree where you add all the user address and the amount of each user will receive from it. So the user, when called, it will prove that he belongs to that tree and will receive the rewards, and then they have a structure to mark that user already received this reward, right? And similar here, we are going to check it right now. So in this one, you can say that it has the program folder. Let me close this first. So you have the program script tests, also really similar to the Ethereum. Then we have the programs here. Inside it, we have our program, the token airdrop, and the folder source. So the first file that we need to check here is the lib, which contains all logic from it. So usually I reduce everything here because there is too much information when you start, and we don't want to get everything at first look. So here, this macro here is like to have the input type of the function. So we have this transfer CPI type, which is a structure that we can record here, the structure type. Then we have like a bunch of macros as the account here, but we can focus only on the variable's name here and the type of it. Similar what we looked at the first slides. So we have the recipient, payer, and the system program. Which one, like when I have doubt about what this means and I don't understand it, I usually get back and search on the Google about it. So like if I want to understand what is the signer, you can go like to documentation on some video that could explain something and get back, like moving from searching and to already reading the code, right? So our main code here is declared inside the token airdrop module. Then also we are going to have here the initialize function which will initialize the Merkle tree, similarly which we have on Ethereum. Then we have the claim function, the set admin for this initialize data function, and lock claims in case you want to not enable to anyone claim the airdrop, right? So to understand a little bit more about the architecture, we are going to have the the instructions folder, which is the entry point of each function. So when you saw this, the folder named instruction, we have like each functionality separated by another file, right? And then we usually have the state folder, which contains the type of the data account that we want to store. So we will have, in this case, let me start from here. We are going to initialize a new Merkle distributor. So we have this function, handle new distributor. To this function, I will have this file, new distributor, and we have the data structure of this distributor here in a state. So in Solana, we have, for almost all the projects that use Anchor, this type of structure. Then we can see this function. We open the new distributor. We will find it here, right? So again, take a look. We have a bunch of declarations here. So the struct, initialize struct, then we have the new distributor struct. We'll have a bunch of macros. But again, we don't need to understand it. These are like helpers which will be checking some logic and will help you. Like, I don't need to check if the owner. I have a macro that help me to check this. And again, while you are getting deeper in the code, you are understand it more. But the idea here is to understand the logic of each function, and probably we may find some bug here. So to add a new distributor, we are going to put the version and the root. This is the Merkle root tree of this. As you can see here above, we are getting the distributor data count here. We are setting some variables to it. So we have the mut keyword. If we didn't have this keyword, probably the code will not work. So we add the version, the root, the minting, the token. We are like setting everything related to this distributor, right? And then we emit an event and finish. So this is initializing a new distributor. After that, we have set the data of this distributor, and any user can call this data and claim the tokens, right? So now we have the claim function here. So the user needs to pass the proof and the amount of tokens that he will get here, the allocation. Again, we have the handle new claim, and where we can find the logic of it, it's in the instructions. So the instructions here, you have the new claim, right? And you can jump directly to the logic of this function, which starts here, handle new claim. At this point, we can have an idea how to read the code, but we can also give a step further to it, so we can check like how this new claim struct is declared. So we have the distributor account, which is the Merkle distributor type. Then we have the claim status, if this account is already claimed, from, and then to, who is claiming, then the token program because Solana is different from Ethereum, so we need to call a program to transfer the tokens. And then usually you have the system program here. So again, the user passes the proof, the amount of allocation, and you can load the distributor, which we just created. Then the account which you claim, then this will verify the Merkle proof. You can also use the comments to help you understand something that don't make sense to you. And then we'll get the hash of the Merkle tree, and we'll check if the proof is added to the root of the Merkle tree. Then we have the status of it. There is one interesting thing because we can't store the data in the program, right? So we have the airdrop program here. We have the Merkle tree data, and we can't store the data of each user directly here. So you create another data extractor, which will contain if the user already claimed or not his. So you add the user info here, the claimant, and the amount of tokens that he is allocated to here. And then we have like this complex code here. We also don't need to understand, but it's like a token transfer. At this point, we just want to know that it's transferred tokens from probably the program to the user, right? And then emit an event from it. So we can also set the admin of the Merkle distributor, and we can also lock claims to this. So like check first the lock claims. So we'll have this function. So right here, we call the handle lock function. Then we can check here the client handle lock claims, right, function. Sorry. Then it's load again the distributor, and in the distributor you have the lock claims variable, and it will set to a Boolean that the user pass here, right? So it's the most easiest code that we could have in Solana, and it's not too much complex. So yeah, a user can claim, the admin can lock it, and you can also change the admin here to another admin. And while we are get into the code, we can check like which is the signer of this account, and here we can check like if the admin, the past admin need to be different here in this case to set the admin, and then the admin could call this function, right? So in this code, we have a logic issue. If anyone could find it while you go just checking the logic, please get up your hand. No? It's like the logic here is you create the Merkle tree, you add the root to it, you can claim it, you can lock it. But if you can check when you claim it, there isn't any checks here to check if this distributor is already closed. So my idea here is that you can already start reading the code. You don't need to care about like what is macro, what is this context type and new claim type. You can take a look, like in this new claim, you have a bunch of variables, but if you can simplify, you could like remove this, remove this, remove this, remove this, remove this one, remove like every comment to make it simple. Then we have a structure type here. The structure is the new claim, and you have these variables inside it: distributor, claim status, from, to, the claimant, token, and system program. So you have an idea of how is the structure of this new claim, and then have this in mind. You will see like you're getting the distributor here, the claimant, which is already defined, then some logic to verify, again, the micro-root, the status, if already claimed or not. So you can already know the logic behind it. I forgot to pass about this state, but this state is here we can declare the data structure. So the new Merkle distribute will have this information inside it, the data account of it. And we could have also some implementations related to it, like if we want, we could add the logic here to verify the hash of it, and instead of declaring it here. Okay. Right. And I don't think we are going to have much time to like dive deep into the routing stake, but similarly, we can have this. Like this is a bit different from the other one. So let me close everything here. So we have the program, the token staking here, the source folder inside it. Then we don't have the state, but they declared here. So here we will find everything related to the pool. So this is a staking program. So similarly, in Ethereum, we have the staking contract where the user put money on it and can withdraw money from it. So you have the same thing here. We call the reward pool. So we have like these variables declared inside it and some implementation, as I said here, when you create a new one, then you can calculate the rewards of this. Then we have the stake pool, which also have some variables inside of it. And like I just got this code where I start looking at it, going to the lib file. So the lib, we have here the program name, and again, initializing the staking pool. You can transfer authorities like transferring the owner, adding a reward to that pool. You can deposit, claim everything, withdraw from it. In this one, we have the slashing function. So the user will stake, and in case it will kind of give him the voting power to an operator, and in case an operator does something bad, then it will slashing this. And like for each function, we have it separated here as well. We can like checking probably the deposit function, which is the easiest one. So we have the structure of the deposit. Again, with some variables, we can try to draw some diagram of it, adding every variables and have everything in mind. But the main function here is the deposit handle, right? You can find it here. So as you can see, this looks like pretty complex at the first time you look, but if you try to read each line and understand it every time, you're going to understand all the code, right? So the user here to deposit, he will add the amount and the lockup duration. Like I want to lock up my deposit for 1 week, for 1 day, for any time. So you pass the pool that you want to deposit, right? And then it will load this pool, check the minimum time of this pool, and check if your time that you input is enough to add it. So it's really different from Ethereum. So we have the pool here, but when the user deposits, you don't start the data directly in the pool. Like for each user deposit, we're going to have a different data set for this deposit. That's why, because we create a new stake deposit receipt from it. And then we add the owner of it, the pool of the user is depositing, the payer, the amount of that user deposit, the effective stake, it's calculated here in this account, in this function. Then we have the lockup duration and the current time of this deposit, right? So I hope you guys understand like how to take a look at the logic. Although we don't have like any idea of how those things really works, just looking at it, you can start checking each line of this function. And as example, I'm not sure like what these things mean, like get effective. You can look at the code if you find this function in another place to understand it, or if you don't have it here, probably is something already predefined by the Solana program, and then you can just give a time from this code, get back to Google, search a little about how these things works, and then get back to it. This is usually my process of how to get a new understanding of new code. Like usually I don't spend too much time getting into tutorials, because what I've already noticed from all of my experience is after you watching like 30 hours of video explain some new language, when you go to some competition or trying to understand some new pattern, you will not remember everything that you have watched. So the idea is to get everything into practice, like, and get back, learn, and then practice reading the code, get back, learn, and do this loop until you can figure out how everything works, and with some time, you will get better, right? So for this, we look at real project architecture, know where is the entry point is located, and try to understand a bit of the logic of each entry point. And now with this, we finish the developer mindset. I do this loop until I can understanding all the code behind it. So like in this presentation, I can't dive deep more into too much details here, because we are probably spend some days trying to understand everything. Like I've spent 1 or 2 weeks learning Solana and understand the code while I've participating in the grass competition, and I could find a medium issue which nobody found it. Then now we have an idea of how to read, how to get everything, and we could start developing our hacking mindset. So again, I have an idea of how Ethereum works. Like I know how the control access works in Ethereum, so the owner just can call some functionalities. We have the same thing here in Solana. If you take a better look at the macros, you can see that there is an access control to it. If you don't have it, probably you can break some of this functionality. We also have arbitrary calls. So when you pass in an account which you didn't verify it properly, you can make any call and calls to another data account and break it. In Rust, we also have underflow and overflow. So in most of the code, we are converting all the values and checking if we don't have any kind of this issue. And then we have also the project vulnerabilities. Like in lending project, usually you have a bad liquidation issue, and these kind of logic issues we can also find in Solana program. So you can reuse everything that you already know and try to find some vulnerabilities in this code. So we'll have like the lending staking program similarly. So we're going to have an incorrect reward calculations and incorrect liquidation, bad liquidation, and all of these logic issues, I put these in project vulnerabilities. And then we also have some Solana common vulnerabilities. You can easily check like Rust common vulnerabilities. You have a list of it. So Solana common vulnerabilities, Ethereum common vulnerabilities. And you can similarly take a look at these things. So in Solana, we have like, we can close an account. If you don't close it properly, you can review this account. Example, the user called the claim in the Merkle distributor. So you add the value to it. You could also just close this data and like to not let the user reopen, but he could, if you don't close it properly, the user could reopen and can again some tokens. We have the account matching. Then when we are defining the structure, you have the type of this account. You don't have this type. So you can add any type of account to it and read, instead of you reading the owner, you are reading some random value from it. We have the type crossplay and reinitialization attack. So if you search for it, we will find like 10 common vulnerabilities that you can already start finding it in Solana projects. So after that, we know that we could have the same issue in Solana. We have these common vulnerabilities, but from now on, how to improve my skills and get better on it. So during my process of improving it, I usually like to create diagrams of the project. So while I start a new competition, I start already drawing the diagrams and make all the flows, because when you're checking the logic, it's similar to Ethereum. So you have some flow that will broke. And then we can also learn some new patterns, like how is a project, a lending project in Solana. After you read a code, understand it, you can easily look at another code and matching those patterns. If the pattern don't match, probably one of them are incorrectly, right? And also searching for vulnerabilities, you can do it looking at Solidity site or looking at old competitions report. So we can also find all the vulnerabilities of a lending protocol searching for all the reports of lending protocol. You can have everything in mind, and then when you're going to make the next audit, you're going to find it faster. Also make POC, it's a good way. In Solana, I currently don't know how to make POC yet. I know how to understand the code, but because POC in Solana is different from Ethereum, like you don't use Rust, you use TypeScript. So it's completely different, and in my opinion, hard to make it yet, right? So doing POC, you can understand if like the logic, the flaw in logic you find, it's really a flaw. Because usually you see a lot of submissions that don't have POC, and there is pretty obviously, if you make one, you could find that is not an issue or it's an issue. And again, put everything in practice. I think this one is the best advice, because while you're practicing, and like I send one issue in a competition, and then I got a feedback there was 15 issues. So I learned from it where I don't find the issue, where to identify the code of this issue, and also have like defined description of how this issue works, right? So following this and having a loop of searching, understanding, you will improve all of your skills. And if there is one thing that I would like to guys remember from this presentation, is that you don't need to understand everything at the first time. You could, like, if you have a full-time job and want to make a competition to learn about Rust, you get one, try a little bit, understand some part of the code, some part you will not understand. But after putting everything in practice, with some time, like 1-2 weeks, you will see a good return of your knowledge. So that's it. Thank you very much, guys. I hope this presentation brings you new ideas how to improve it. And if you have any question, we can use it some minutes. No? Good. I hope I can explain better. Everything. Thank you very much.
Hi, it's very nice to have you here. And I want to ask a question. You mentioned about the Solana POC. So how do you fork a state of Solana and so that you can reproduce the hack?
All right, I've already searched about it, how to fork the state, and like, I don't think there is a way to do it right now. I think there are some complex steps that you need to do to fork a state and work on it. So like most of the POCs that I've checked, they create from zero. Like you have to declare everything, like to create a state and then use it to try to break it. So there is not an easy way that I can fork, like similar to Ethereum, you can just fork using Foundry and execute something in the contract. In Solana, you don't have it. So you have to code it to make it to that state yet. I think they are working to have something easier to do related to this.
Thank you.